Okay, we will now do question number 25, which is to find the magnitude of the angular momentum of the two-satellite system, or to find what best represents it. So the options are A, the absolute value of m1 times v1 plus m2 times v2, B, the absolute value of m1 times v1 minus m2 times v2, C, the absolute value of m1 v1 r1 plus m2 v2 r2, D, the absolute value of m1 v1 r1 minus m2 v2 r2, or E, the absolute value of m1 v1 divided by r1 plus m1 v, or m2 v2 divided by r2. So we're going to want to, since it's asking about the angular momentum is the radius cross the linear momentum. So the total of this is going to be the radius 1 cross linear momentum 1 plus radius 2 cross linear momentum 2, like that. So next what we're going to want to do is we're going to want to find the linear momentum of each. So the linear momentum, P, is the mass times the velocity. So m1 v1 is equal to p1, and p2 is equal to m2 v2. So the angular momentum is equal to r1 m1 v1, and then we add r2 m2, and since the velocity is in the opposite direction, since the velocity 2 is in the opposite direction of velocity 1, it's going to be negative. So that's times negative velocity 2. So that means what that means is that r1 m1 v1 minus r2 m2 v2 is the linear momentum. And the magnitude of that would just be the absolute value. So that's how we find our answer. 25 is D. The absolute value of m1 v1 r1 minus m2 v2 r2. So right, yeah, so but the when you add the absolute value to make it a magnitude, it's no longer a vector. I wrote it as a vector. That's not correct. It is simply L equals the absolute value of R1 M1 V1 minus R2 M2 V2. Yeah, that's pretty much